Okay, we're live. Who would have guessed? Seems fine. Since I don't have to go. And also this. A show today, Atmel makes beautiful microcontrollers. See, we've hit a problem with an interpreter last time. Which I don't know how, actually. Like now when I think about it. This thing should have worked just fine. This should have been wrapped like just as before. And then where is it? Symbol. Here where it's evaluated. Set it evaluated. Then we check the type. Our hash type equals this. Well, actually, okay, so if symbol type, I need to like relock it so it's immutable. That's a problem. I don't know how to do it else. So we drop symbol mute, or should probably call symbol locked. Symbol locked. Then we do that symbol locked equals symbol lock. Wait, not lock. Try read and wrap. If the type is type function, then we do this. Wrap as ref function. Qualify this as an expression function. Expected span type found in num type. Inner. Welcome in, Nigel. No. Self. Just type inference. Welcome in Freedom Forge Studios. Was not expecting that. Oh, I could just do type inference, no? Here. Dot. Come on, formatting. What's wrong? Value moved. Oh wait, semicolon. Yes, ref. Borrow moved value. How is it moved? By the way, Freedom, you don't know that plushes are now controllable? If you do plush, you can control it. Well, if you do the command and provide. So there is a heat extension somewhere here. You click on that, go into access grant, and then you'll be able to control plushes by clicking on the screen. Borrow moved value. Why is it moved? It is dropped here. It is recreated here. Oh wait, I've missed. This is a typo. Okay, expected. As expected. Okay, now this should work. This should run. I don't know why it didn't work yesterday. Oh, and also, interpreter does not have to have a type inference. Doesn't have to. Struct defined here with zero lifetime parameters. Okay, so this is crashing for some reason. I have no idea why. Where's the gedit? Now we start each stream with Z, even though I might like other editors better. Please don't redeem. No. Where are lifetimes? And why is it crashing? I guess we're gonna switch to VS Code just to debug this thing. Because I have no idea how to debug with that. And I mean, the functionality is here, but I don't know how to use it. Okay, so this is just an interpreter. Yeah, Helix also has debugging experimental, but at the same time, I don't know how to use it in Helix. I only know how to debug in VS Code and NetBeans. Such a weird combination, but that's exactly what I know. Because I love Java. I've used it so much before, and I've used NetBeans. Okay, so simple did compile. And it didn't do anything, obviously, because commented out. Why calculator doesn't? I wonder how or why. So it's somewhere where there is a literal like that. How can it be resolved? Because it's just parsed. Let's print it. Let's do some print debugging. Which we all love. We all know and love it. Symbol here. Before evaluating it. Oh wait. Yeah, before evaluating it. Value finish and check types. Finish here before evaluating it. I'm gonna print a line symbol locked value. Okay, so first thing we get is a function. Don't even know what this function is. Oh, this is fast poll. Unresolved. Everything is unresolved, see? Why would it panic then? Symbol. Should probably do something like that. Self. Symbol is Y. What? What? Where? How? All the symbols are unresolved. How can it be resolved? Literally just print it and then interpret it. What? How is it resolved? Only I could print outside of it. So I print self, which is says Y, that means it's a variable. When can it resolve? Huh. Wait, I'm printing a value. No, I'm printing a value, which is unresolved, and then I'm cloning it. For some reason, it panics. If I do clone here, it will panic, right? No, it doesn't. What? No, I actually don't understand. Here, I'm just cloning a value. And what I'm doing inside of evaluate, which is a function, I'm just cloning a value. I'm literally just cloning it. It doesn't make sense. Well, maybe actually it does clone. But I mean, here I clone it just clones. And it prints. We can see that it prints. Before one. Good old print debugging. After one, after two. What? Okay, so it is wait, what? Where does it get cloned? Okay, let's do Raspberry. Should have done this before. Okay, so this is inside of a symbol, obviously. Here. Then we go up inside of a get symbol. Oh, what? Okay, hold on. Oh no. So I need this to be clonable, but at the same time, like not always clonable. Okay, so I mean I can extract this, make this clonable again, clone. Go to expression. So when it is an expression, can I clone? Can I convert to manual implementation? This is kind of sad, and it doesn't even want to implement it properly. We'll have this symbol reference here. Come on. Spend symbol reference, box of dynamic metadata. So yeah, this is symbol reference. If symbol dot inner, if not matches, oh it actually does not equal to symbol reference. Wait, unresolved matches actually. Not matches this to unresolved. Then we do a symbol. I mean, I just want a normal clone, but instead, but like in one specific case, I want to panic, and that's like super annoying. This is just annoying. I don't want to deal with this. So much work that Rust could have done for me. Only if this, if only not the specific case. I mean, I can make AI do stuff for me. Oh wait, we don't have AI in here. I forgot. Expression module clone. Function clone. This is extremely tedious. I don't like this. Let me move this down. Move this over here. This is like extremely annoying. Because I'm just doing default implementation. Except for one specific case, for this one match arm. That's so annoying. Constant. I mean, I can do it, but then I need to update it. And it takes space. It takes space in my code. It stops me from going from spend to display quickly. Requires additional scrolling. I don't know what the second thing is. What is this? Oh, meta. Symbol. Expression. Symbol. Clone. Meta. The clone. Binary expression. Expression. Actually, can we do? Can at least do this. Wait. The binary expression. Oh wait, it doesn't work like that. Never mind. Binary expression. Binary expression clone, and I have to do this like 10 times. This is so annoying. And I can just do expr. Because I don't want lines to be wrapping. Do expr here, and then also I can replace all the expression here by self. Actually, self here self Next we have this replaceable by self. And metadata can be renamed to meta. Can this be, yay, it can be one line. This can be cloned, and this is a unary. Why is it suggesting me to borrow? Still don't understand. Expected binary expression, found unary expression. What? Wait, no. Oh, and this can be placed to self. This should be self. This should be self block. Self block clone. If can I just do if? I don't know. Self if clone, or I can just do expr. Expr. I mean, I can do raw if, but I feel like expr fits here a little better. Call self call clone. Expr self return expr clone. Declaration. Can I do that decl? Because it's gonna wrap line. Variable declaration decl clone. Otherwise it would wrap lines, and I don't want that. I want everything to be one line except this case. Assignment self assignment. I mean, I can just do expr. Expr. And then error also gonna be cloned. Error. Self error. Why are you borrowing? Come on. Error clone. Okay, now. Oh, I can also do same thing here, by the way. Self, why? I mean, I don't understand why Rust Analyzer doesn't do this. Like, if I ask it to inline all the variants, for example, it's so much more concise. There's self. Why? This is, oh, that's a lot of stuff. Yeah, this function is kind of for a language. Just this function is actually just to format stuff properly. Oh wait, no, this is also for parser, which is kind of absurd. Self. Soding has a word that he likes to say, bizarre. Now, for me, the same word would be absurd. I guess. Oh, see, this line is now one line. This is awesome. We can also rename this to meta, just for it to be a little shorter. Self. Okay. Now. Oh, it's just an edit. I thought it was the morning. Okay, now. I've moved this thing. Now, should this work? Clone for symbol reference. Oh wait, I didn't remove this thing. Now this should work. That's why we have a calculator example. To test stuff that's more complex. I mean, so on and so forth. This is just. I mean, I don't see him saying that it too often. Only where it makes sense. But bizarre, he's like using this word like he's addicted, like he's addicted to it. And I'm saying absurd way too often. Also, like I should probably replace this word by something else, but I don't know of synonyms. I guess bizarre is a synonym, kinda. Every time I say absurd, something just pops up in my head and says bizarre. Um. Okay. Expression self. Yeah. Ad breaks coming. Get symbol and stuff. Okay, so this works. Now, what did we do? Oh wait, we didn't. We didn't do the thing. We need to do the thing symbol first. Here in the ensure evaluated. Why we did this whole refactoring stuff? And by the way, I don't need those prints. Is so we can I refactor this to be a match? I mean, I can, but it's not gonna. It's gonna require some manual stuff, manual work. So move out. Oh, I miss missing my charms. Oops. So here we do a module. That's why like the whole refactor basically started. Well, kinda. Well, refactor. I mean, that's what we were going to do initially. Anyway, let's just do it. It has started. Module. So this we just converted to module and rename this to module. Here, how easy it is. How easy is that? Oh, it's not an expression, it's just module. So it's first class values. We literally can cast a pointer to a module. How nice is it? Because literally our values are literally the values. It's so easy to interface. Like with Python, for example. Okay, this thing works. I mean, simple Oracle. Now here we have a module which also got all stuff, I guess. This is wildcard. This shouldn't be wildcard. What? Huh. Oh wait, we have inference check types for a module. Should we really have inference check types, or should we have Oh wait, inference check types doesn't sure evaluated. What? Oh wait, putes is a no, putes is an external function. Why the type is not here? So ensure evaluated should theoretically equate finish the type. It finishes the type of the symbol. What's wrong? Why the type of the symbol is not finished? Okay, let's do another simple test. Let's put a function in here that will have a variable in it. So it will take an argument and it will square it, for example. Well, b equals a times a, and let's return b. Now let's see. It should infer. Okay, so those are all unresolved and not inferred. I mean, makes sense, kinda. One symbol. Well, actually, here in display for symbol, if it's a function, oh yeah, I forgot this. If get type is module, evaluated as module. So this hard coding stuff is just like here I'm displaying the value which is not evaluated, and here, which I should probably replace this by a type now. Here I'm displaying a type. I mean not a type, the evaluated value. So the value that has been evaluated, inferred, and checked. And can I do equality like that? No, Inner saves us. Inner. Okay, now this thing should work. Okay, now everything is inferred and I guess checked as well. I mean, it was checked and inferred before. Now at least we can see it. So git add, git commit modules, git push. Now we need to actually access stuff inside modules and build them properly. Because right now if we compile simple, so this thing generates foo.o, I'm pretty sure. Yeah, it generates foo.o. Now let's do something I haven't done in a while. Let's read the object file. And I don't remember how to. Display sections. Like I need to display object file export import symbols. I don't remember how to do this. Yeah, something like that. Objdam dash t or dash t demangle. Ooh. Yeah, we'll need to work with mangling as well. And interesting thing is that mangling comes today. Okay, objdam dash t, I guess. Foo.o. Dynamic symbol table. This is static symbol table. But I mean, I need to see imports. So there's a local symbol foo, which is the object file itself. Then there's global symbol main. How do I view imports? nm-c which down view imports. I mean, I don't want executable. Read elf-d. I mean, that's dash d. That's for executable. Object file. I don't think that's it. I mean, I've done this somehow and I lost the command. I remember having trouble to find this command. Elf object file. Import names nm -d -t. Well, I mean, do I have an m? Do I have lowercase d? Okay, what nm wants from me? Oh, that's a lot of stuff. nm options file, list symbols in file, a.out. Ooh, that's cool. Debugger only symbols, cd mangle, d dynamic. Ooh, I can just do nm, right? Okay, displays main. How do I display imports? Format g extern only dash g. Okay. Anything else? Defined, undefined. Okay, I guess I just do dash g or whatever this was. No, still same. G is extern, right? Extern only. Huh. How do I display import symbols? Okay, maybe there are no import symbols. Maybe that's the thing. I mean, probably. Well, actually, yes, there are no display, no import symbols. I'm trying to find them. Okay, let's do objdump again. Okay, now we can see the putS, and now if we do an m, which is much nicer, we can see the putS, which is undefined for some reason. I don't know why it's undefined, but I guess we're learning how to use links commands, those elf analyzation tools. Anyway, now let's say yes. I guess let's actually build this thing. Let's actually build the imports. So if we go into where's it? Mod rs. Wait, no, it's librs actually in the backend. So there's an object, root module, objects, etc. New root module, build object, build root. Okay. Now we can create the object. Now if I extract this thing out, now it's object file, constant data. Okay, so now I do object build or something like this. Build module actually, public function. Okay, let me actually cut this function out and move it into another file. Declare and build modules. Public mod module. Create module rs. Pretty simple, right? So we're gonna use super asterisk. Then we're gonna do impl object. Okay, now here we will have build module. I guess, or I mean Orco IR module. Object anonymous lifetime. We don't care about the lifetime now. Right now, borrow that. And then we'll go through module symbols. For each symbol, we log the symbols, and if it's evaluated, if it's a function, we declare it in self. If it's an external function, we declare in external function. That's declaration steps. Then we go through the symbols again, and then if it's a function, we build it self. And yeah, constants are handled outside. Oh, this should also take self, which actually mutably. And it probably should also take some kind of path, but for now it doesn't really matter. Well, actually it does matter. Anyway, get type. Oh, it does matter. But we can ignore for now. External function. Okay, so this is match. We can copy this match, not match. Now we can copy this, paste here, type module. Anything else unhandled here. Now if this is a module, value is module. This is now a module. Self build module. Literally, I can just pass in module, and also path is gonna be. Okay, so we're gonna pass in path. Do we own it, or do we borrow it? I think I mean, like, let me think. I think it doesn't really matter actually. We can own it. So we're gonna do pass extend add here. with a symbol name, or what, extend action. Extend push okay, so it basically clones. I mean, I can pass a borrow here, but it doesn't really matter. I guess I'll leave it as I mean, yeah, I should probably pass in borrowed. So here we also extend it. Extend function name clone. Declare function takes name as a path. I should probably borrow it here because it doesn't really. Oh no, I can't. I mean, I shouldn't. I can, but I shouldn't. Here, build function takes path extend symbol name clone expected borrowed path found path. Sure, borrowed. And then here module we pass in module, and then we pass in path, which is gonna be the normal path extend symbol name. Okay, now here we need to fix this call object root. I mean this isn't really possible. Borrow checker is just gonna be so angry at this. Well, actually, I mean, I can just put root here. I don't even know why I pass in root. Pass empty. Am I even using the root? What's wrong? Build module. What? Oh, I can just do new. Okay, new. Okay. Expected borrowed path, sure. Now, am I even using the root anywhere? Because I don't know where would it be used, actually. Like, G Shift A. No, I'm not using it. I have no idea why I need it in the first place. I mean, all the resolution is done beforehand, so shouldn't really matter. Oh, and we don't need a lifetime then, which is nice. Always nice. And then we won't need a lifetime in a lot of other places. Which, yeah, kinda tedious to remove them now. But sure, we can do this. Can do this. Oh, that's a lot. Come on, are you gonna end? Yeah, I mean, every place where we build something, there's this anonymous lifetime. Pool doesn't require this thing. What? No, it does. Okay. Save that. Save that. No lifetimes here. Here. X. Why did I press X? Here. Here. So hard to retrain to use D instead of X. Okay, next we need to go here. Then here, I guess. Here, I guess. Oh, what's missing docs? Build a module prefixing all its symbols by path. Okay, okay. Okay. Okay, now should work. We should be compiling modules now properly. And if we look closely, okay, they are here. Now I wonder if it's gonna, how it's gonna work, how it's gonna look. I mean, the import table should be just the same, but because we have put s here, not like here, this name doesn't matter. For building, this name matters. Let's go to simple. We add a function comp time test equals fn, which doesn't do anything. Now I wonder what's gonna happen. So the test case name is colon in a test case name. Oh, that's that's so cool. Now this thing should be exported actually. Yo, we have exported names with double colon. That's cool. I don't know how it's possible, but that's cool. Okay. Now, git add this, git commit dash m building modules. And where am I committing actually to? Clicking. We're getting closer and closer to pass operators. Actually, like if we go to readme, technically we can mark this one. Well, actually we can't mark it. We didn't experiment with it being borrowing names. We need to get the pass working first, and then we'll see the full scopes of them. The full scope of them. Then I mean, this is not that important. It can be done actually. I should probably move traits quite a bit closer because they are very important. I will move them after comp times. Fine. We'll get one to-do item of rest, and then we'll get the traits. Oh, I still not sure how to implement them, but there shouldn't be like anything that hard. Okay. Oh, we're committing to literally to master. Wow. Okay, sure. We're just doing the roadmap. It's not any crazy branch. Okay, so now we need pass. We need a pass operator. Go to expression, mode rs. I mean, double colon is just a binary operator technically. And I mean, binary. Well, no, hold on, no. It's not just a general binary operator. It is a specific operator. How do we call a colon operator? Or operator. Scope resolution operator. Do we name it scope? Scope expression. Scope. How do we name? Okay, let's ask AI. Doesn't care. I don't know how to name this thing. How do I name an expression of using colon operator to access something in a namespace? No, there is no plushie for Po. I mean, I could add one. It's pretty simple. And I kinda use this thing quite a bit too often. This is a scope in C++ or PHP? Excuse me? Scope resolution, I guess. You've seen that logo before? I mean, I think I saw it only in Po. Here it is. This is ChatGPT logo, this is Po logo. Okay, sure. We're gonna name it scope resolution expression. Compared to Gemini, Llama, GPT-4o Mini. Scope resolution. One thing is the left-hand side is a general expression, but the right-hand side is a name, which I probably should extract this into a struct, I guess. Yeah, I should extract this into a struct. Scope resolution, and I guess this goes into a symbol reference. Public use symbol reference scope resolution. Okay, let me just move the thing. Move it here. Okay, now let's go into symbol reference actually and create a scope resolution operator. Oh, that's a lot of stuff. There's an internal pointer at the bottom. Public struct scope resolution expression. When are they gonna add arbitrary scripts to that? Arbitrary extensions. Okay, so expression, or actually like the scope. Okay, let's do the scope, and then the name. The name is literally a span, so we don't need to span it. We probably want. Oh, I mean, we don't need to span the expression. We can span the whole thing. Okay, let's create a new for it. Oh wait, and metadata, obviously, and make it all public. Okay, actually, this is not true NeoVim. This is not a true NeoVim experience. Let's write all the docs. Scope to access a symbol from name of the symbol, and then we'll have a span of the symbol. Wait, span of the expression, of the whole expression, and we'll also have metadata. Front end metadata. Can I go to branching just to look up how metadata is formatted? Oh, and also span should probably be ignored as well. Completely forgot how to create those expressions. Need to do all of the derives. Okay, metadata. Scope resolution metadata. Yeah, I mean, do we need this thing? Probably, yeah. Need to simplify expressions. Yeah, we actually like one interesting thing is when traits are gonna be in place, I'll probably get rid of binary and unary expressions completely, because why? They are not interesting, they're not fun. Why would I use them? I can just replace them by traits and function calls. That's like one of the ideas. And also I might remove, I mean, no, I can't remove a call. Yeah, return is gonna be removed in favor of unwinding, probably, hopefully. Assignment is also in favor of, well, actually, maybe, no, probably assignment is still gonna be an assignment expression, but it's not gonna be operator overloadable. Yes, scope resolution and stuff like that. Functions, modules. I mean, I'm also not sure about those things, but I guess this is just language. So ideally, you'd be able to do something like comp time libc equals parse c headers, and this function is gonna take a path get env var libc path. That's how you're gonna write your projects, right? Then you'll have comp time main module equals parse rust code and this is gonna take src. This is like ideally how we would have this whole thing set up. I mean, maybe not ideally, but this is a pretty cool way that's gonna be possible. Probably. I mean, not probably, yeah. It should be possible. Okay, metadata. Now we implement it, we declare metadata for it. Okay, let's create a new function, generate new for this struct. Yes, scope is expression. Does binary wait, operator. Does this thing take, yeah, it takes boxes, and the metadata takes impl this plus static, I think. Alright. Do we have to give it a static lifetime? Yeah, I do. And then metadata is gonna be box new metadata. Okay, then we declare metadata of. I mean, I can just copy it. Here where AI would be actually useful. It can just copy paste things and adapt them. It's just kind of nice to have. Trait scope resolution meta data. Resolution metadata. Now this thing should be a fully fledged operator. Oh wait, we need to fill it up here. Scope resolution expression. Wait, operator. Wait, no. I felt like I wrote an operator somewhere. Get type. I mean, do I need the get type? Yeah, I need the get type function. Public function get type. Oh, and I need to fill in docs for the new function, for example. Create a new scope resolution expression. Get type of the resolved symbol. So this is the hard part, kinda. This takes borrows self. Yeah, this should just borrow self and return type. Don't even know how to do it. I mean, I'm gonna have to match stuff in here. Okay, let me just implement all of those one by one. Scope, resolution, expression, infer types. Same thing for checking them. Finish and check. Finish and check types. Now, span. Where is it? Symbol. Okay, I'm gonna have expert scope resolution. Basically the same. So now here, clone is literally the same. Scope resolution. Scope resolution. Why do you want to borrow so badly in the clone? It doesn't make any sense. Scope resolution. This one is even simpler. Okay, now We need get type, finish, and check types, infer them. Finish and get, finish, infer and check. Get, infer, finish, and check. Okay, here. We'll copy that. Just to copy the signatures. Yeah, we are yet to create structs and stuff like that. Okay, now. Get type. So we need to get a scope. Oh, we can just okay. So we do scope. Oh wait, we need to literally evaluate the scope to get a type. I don't know how to do this. Oh, we don't yet have a symbol. Oh wait, no, we do. We do have symbol references. Huh. So this is a compile time operator, basically. Didn't think this part would be hard part. This should be an easy part. Let's look at what we need to do. So here we have libc, which is a symbol reference expression. Now, in order for this operator to work, we need to get libc, we need to get its value. I don't even know. Like, scope resolution. Yeah, technically scope resolution has to evaluate whatever is to the left of it. Which is kind of hard. Because remember, we don't store signatures and types. So this type is just a function. It's not a function that doesn't take any parameters and returns size32, it's just a function. Because the signature is part of a value. So what do we do here? I mean, we can try to evaluate it. But there's gonna be a second place where we evaluate stuff. So, I mean, theoretically, you can then do this, or even this. Ooh, that's kind of crazy. I mean, theoretically, if we literally go and evaluate this part, we can do this. We can. I mean, is it really what we're going for? If we evaluate it, it should be evaluated once. So we should have a cache. We should have a cache. Okay, let's go like symbols and just evaluate them. Let's close all of this. Open symbol rs. Clone that. Evaluate it. Put this here. And I mean, yeah, ensure evaluate. I mean, this is a complex thing. Technically we need to. I mean, technically we need to infer and check types for this thing. I don't even know how to do this. Like, when this expression is gonna get inferred and checked types? This should be like, I mean, yeah, this should be before evaluation, but then we need to evaluate and then we need to check it again. Which is problematic. Okay, I'm not sure. Do we leave this possible? I think we leave this possible. Probably. But I mean, this introduces basically another way to comp time evaluate stuff, which I'm not really a fan of. We still need to put symbols into this thing, into the blocks. Evaluated resolution. Oh, and we need to clone it. We need to convert clone to a manual implementation after this, which is even more annoying. Come on, Rust can't even convert to clone properly. Can't even create a manual implementation of clone properly. Span, self-span, clone. Metadata. Come on, can't you? I just don't understand why it doesn't want to format. Oh, I do understand it. Now, that's better. So I guess we evaluate it. I mean, now we need to pass in type inference where we don't want it to pass. Well, actually, I mean, we can just do symbol exactly as we do symbol. Well, not exactly, because symbol splits into two parts, but I mean, pretty simple. Self, so we do self-evaluated expect. There's an error message here. So if evaluated is none, we just return an error. We don't even expect it. If self-evaluated let value equals self-evaluated, this is sum, else return type error. I am using this kind of often now. I'm kind of wondering if I can create a question mark operator, but nah, maybe later. I think it actually fits here pretty well. So here we can do type get type. Okay, so here we have value. Now we need value. We need to somehow get its type as well. And okay, so we match self value with self scope. Get type. I mean, value is already existing. So this is not just evaluated, this is scope evaluated, I guess. So we do this, we rename this to scope. Now we match, if this is a type module, then we're gonna do stuff. Anything else, type error. Okay, so here we do let module equals scope as ref module. Now module, we need to find a symbol in it. Symbols get self name. Okay, I I actually need this pattern to be optimized. So I do this again. Let some symbol equals this else. Well, this is basically a symbol reference. This is basically a symbol reference. This operator. It is a syntactic sugar for a symbol reference. Hold on. This is like, this is actually just a symbol reference. I'm just copy pasting the I mean, I'm not copy pasting it, I'm re-implementing the code from here. Can I reuse it somehow? Type error. I don't know if I can if I can reuse it somehow. What's wrong? Oh, semicolon. because this symbol, okay, now I resolved the symbol. Now I can just go here. Where's get type? Here I have a symbol. Now I have to do this basically, and I don't want to. Symbol variable. Okay, unresolved path. Okay, that's why we have a path operator. That's why we have a path here actually. Um. Okay, so we need to cancel this thing. Okay, what do we do then? Then this thing actually should take a path. Then this is not really possible. Anyway, if this thing takes a path, do I just remove all everything we did? I guess yeah. Hmm. Look, the thing is that actually, okay, I'm gonna make more of those unresolved symbols. And I guess I'm discarding all of this. Yeah, I'm discarding all of this. And this, yeah, this can be still here. Okay, now I guess we do with path operator. What? Oh, okay, discard. Yeah, no, I don't want to overwrite it. I want to discard my changes. Yeah, I want the file from disk, basically. Okay, now, how do I do this? Should all cancel to an unresolved or resolved symbol? Well, actually, I can do prefixed unresolved symbol. Same thing as here. Prefixed or scoped. I don't I don't know how to call it. Scope access. Unresolved symbol from a scope. So we do symbol reference here on the left side. We go to expression mode rs. Can we actually just clone symbol references? Now I need to think about it. I mean, I guess we can. Still, okay, so symbol reference here would spend symbol reference and then symbol metadata. So we can just do spend symbol reference here, and then a name, and then also a span, I guess. Oh wait, we don't need to span. Span is part of a top level thing. Span of a box or box. I guess box of span symbol reference. Okay, now scope access. And also now here in the clone, wait, not here, in the expression mode rs. This was meant to be easy. I mean, it is relatively easy. I think I got it. I got how to implement it. Not much. Symbol inner unresolved or symbol reference scope access. Okay. Can I actually convert this to match? Oh, I need an arm. Match symbol inner. This will yield just a clone. Anything else is gonna yield this. And this is probably a comma here. And I can remove this, I guess. Right? No? Wrong? Am I wrong? No way I'm wrong. Should just be fine. So if we indent this properly. Oh, I don't close the body now. Now this formatted properly. Meta. Okay, now here I can just, for the scope access, I do the same thing but differently. Scope access. Scope name. Okay, so this thing does not take a path anymore, I guess. I guess this thing does not take a path anymore. It takes a name. Unresolved symbol from scope. Yeah. Symbol reference. The name. Scope access doesn't matter, and this should also probably be this. Okay, so here we resolve symbol. This is gonna be a name. Resolve symbol. Well, get symbol name. Module should probably have a reference to its parent module. Optional, obviously, but let's actually go to readme. We'll be right back. Okay, I'm back. Okay. So what's here? I wanted to put a to-do list, to-do item for. Okay, this is a minor one. Parent modules. Super call. Like that. Okay, so here this is pretty simple. Resolve. So this will be renamed to resolve global symbol. Ooh, F2 renaming works inside of a macro. That's fancy. Resolve symbol. Resolve symbol. Resolve symbol inside of a scope. So here, inference scope, which is yes, module or whatever. Maybe a value. Should I put a value here? Can put a value here. Okay. Okay, and then I should also then I need to put a type here as well. Okay, I'll take care of it later. Then symbol not found should also take this. This will be a name. Solved symbol. Can you show me all the instances of unresolved, which maybe I should rename? Okay, so in the parser we don't care about it. Here I would like to rename this to name, not path. Okay. Expected reference font span. Okay, yes, symbol not found also. I mean, do I say path or do I say like what do I put in here? That's not, no, that's hard. That's actually hard. Hmm. I mean, I shouldn't give it path. I guess I'll do global symbol not found. Global, which will take a name. Name, which is just a name, and then there will be a. So I will have a soft scoped symbol. Scoped symbol. So we'll have resolve global symbol, scoped symbol. Well, actually, this thing should probably report an error just by itself, or should it? Maybe. Do I put errors inside of those resolvers? And why is it all like that? Oh, scoped symbol not found. So the scope value, which I need to type also. Yes. And yeah, scope value I should borrow here. Could not be found in scope. I would just put scope here, but I can't just I can't just say scope here. I mean I can, but it's not gonna work. It's gonna crash because this scope does not have display on it. I mean I can do like scope expression. I can't put I can't put the entire expression here. Which is reference to spent symbol reference. Expressions, the scope, also the scope type, I guess, which will be a type here. Do I really put a type in here? Actually, okay. So display scope x result symbol. So this is not a path. This is a name. I renamed it, it didn't work. Okay, I guess. So scope name. Oh. Okay, so we do scope. Well, actually, I can do it literally here. Scope, oops, name. Can I just do name? Can I just literally do name here? I mean, I can put it like name. Can put it like in triangular parentheses because it's unresolved. Okay, variable symbol. Okay, I guess. Scope access. Okay, so scope name. Let's go to infer types. Get the okay, get widget error out here. I have a scope and a name. Resolve scoped symbol. Type inference scope. I mean, do I just pass the scope as a as as this? Do I call it from inside the function? I mean, no, I can't just call it from inside the function. Calling of those reporters is done in a way different spot, in a different place. It's done here. Okay, so resolve scoped symbol. I can pass in just the scope and the name. Yeah, name. Okay. Now the scope is gonna be borrow spend scope. Wait, not scope, symbol reference. No, is this right? It's just gonna work. I guess, yeah. I guess so. And then I can do here it's scope access. Oh, this is still path, come on. I've renamed it to name everywhere. No? Scope name. Scoped symbol not found. Scope name. Span clone. Okay. No, I'm passing only the scope expression, which will rename to scope. Just remove this. I mean, it can be reevaluated theoretically. Name span option. Scope span scope. Scope symbol reference. Name okay. Okay, seems like all fine. Now we can just implement those functions. Haskell. Yay. Are you brave enough? Wait. Do this. Can I wait? I'm dragging your own. Your Haskell. Let's compete. Let's see who gets more. Come on, come on, come on, come on, come on, come on. Get in. Raylip. Raylip. You can't just leave Haskell there. No. Oh, thank you. This kinda. Oh, I'm. Well, I need to grab my plushes, not yours. How can I get this in? This is just. Okay, come on, you can do this. You can do it. Cheated twice. No, I haven't cheated. I just used your help. Okay, I'm gonna try. This doesn't count. Um, hold on, let me bring this back. Hey, doesn't count. Okay, this is my plushie. Eh. Okay, I can give you away. T2SD is live, by the way. Since you want me to notify you of live channels. Come on, come on, come on. Ah, come on. No. Okay, let's do plasma. I can do this. Lua. The one you did yesterday. I would never think I would stream every day, to be honest. But yeah, this is happening. Давнение. Haskell. Okay. Oh, you did this so cleanly. This was so clean. Hey, what? Why is drawing? Is Haskell is mine, right? What? Wait, what? Okay, I'm gonna leave you the basket. You can have fun with it. I can help your Java fit in. Another Java. Well, what? It doesn't count. I'm not gonna let you just throw stuff in. Or was it mine? No, it wasn't mine. Okay. Okay, I don't know if it actually still carries the viewer ID. Which is a good question. If it does. Let me just throw it out so I can fit in where it was supposed to be. Right under the ring. What is this? I'm scared to click the link. Honestly. What is it? I mean, I'm not scared because your links are normally fine. But still, what? Yeah, you don't. I mean, Drnia doesn't send NSFW. But
Yes,
I have 28 kills!
I know.
How many do you have?
0,
How many do the other 3 buttery smooth buddies have?
0.
Now look at my ping!
You're pinging?
Look at it! What does that number say?
274.
My ping is insanely high, huh?
Yes. I don't even know how you're killing people like that.
Now extend it!
What do you mean extend it?
Extend it! What does that number say?
I don't know. It's hard to read it without the commas.
My ping is so high I have to press all my controls 1 round ahead of time!
How is that even possible?
See that guy I just killed?
Yes.
I shot him 2 minutes and 36 seconds ago!
How?
I had to predict all my 28 kills and the rest of my team can't even get 1 kill!
I'm sorry.
You guys are so brain dead for making me want to say words I'm not allowed to say!
I'm sorry. We should have surrendered. I'm sorry.
You wanna know the best part?
What?
Best part is that you're probably sitting on a $300 gaming chair you bought because you think you're a gamer! I'm sitting on a literal skull chair! The one with the 3 holes in the middle!
this is kind of sad. Okay, this sound is gonna play once you. The thing is, this latency yet. So true. This one is gonna play once you get 28 shots in a row. If you actually master it. I mean, theoretically you can master it. It's pretty easy. But okay. Okay, we need to actually write the resolver, which is the most important part actually. Scope, wait, we don't infer it and we don't check it. I mean, you don't have to. The basketball redeem is for me. You can just do a plush and ask me. I can press the key combination and summon the basket for free. You can practice for free. Fairies. Fairies. Ooh. Now it's stuck. Oops. I might have touched it. Maybe not. Okay, so what? By game. Ow! Hey! Hey, what's happening? What's happening? Like when you get plushie in, it plays a sound and it creates another plushie which you also can control. Because the plushie you put in was your plushie. And can you please Ow. Okay, let me doesn't count. Doesn't count. Yeah, I should probably create like a way to extend the basket time. Oh, and this was my mouse, right? Should move my mouse somewhere here, and it's fish. It's fish. It's fish. You don't know what fish is? It's literally fish. Wait, I don't have fish installed. Mix packages. Fish. It's the fish. You don't know what the fish is? It's fish. Friendly interactive shell. Oh, double sending. I mean, I feel like I saw it once on the overlay. Event channel point redemption ad. What? Custom reward redemption ad. What is that? Freedom. Wait, is it? Oh, I thought I scrolled to the end. No, I didn't. Okay, so you did do twice. And I can see every click you do. Okay. So that was stream streak reward. No, stream streak is not a reward. Stream streak is not a reward. Stream streak does not even get sent, I think. Unless you like send a message with it. And then it's gonna also display some stuff, but I don't think I have, I mean, I don't think I have, I know for sure I don't see. Yeah, you got 450 points. Like, I don't know if we go to, I mean, here, I mean, I can't see my streak for sure. I don't know. I actually maybe, I mean, probably, I mean, yeah, sure. I can't, I can't see my streak because I can't watch my stream properly. So the streak won't make sense. Can we open some random live channel and see the streak? Okay. If I open T2SDE, for example. Can I see my streak? I mean, I don't have a streak here. Ooh. It doesn't display, I guess. Yeah, Twitch changed it. Because I mean, I don't have a streak in T2's channel. And I don't think Ajax restarted the stream. I mean, I should have a streak in Okaline's channel. But I mean, I think it was displayed already and... Yeah, it was displayed already, I can't view it again. Okay, we're here not to watch other people's streams, sadly. We are here to do stuff. Scope, infer types. Wait, finish and check. Types. Span. Ooh. Scope span. Type inference, metadata. Ooh, I don't have Scope's metadata. I mean, I can just pass my metadata in here. I guess it's fine. Assuming that all scopes have the same metadata. Okay, so I do scope inner because otherwise it won't work. And is finish and check. Why finish and check types takes immutable self? I have no idea. I'm not sure if it should. infer types, I guess the same way. Oh wait, it doesn't take span. Okay, now that's better. And this is mutable. Okay. So resolve scoped. Now I need to scope. So scope has been evaluated, I guess. How get types working here? Oh, it's so I need to resolve it somehow. So I need to get the value of the scope. I wonder how. So if it's a symbol reference to a symbol which is a module, I guess that's how. So I guess I just do match scope. I mean, can I just do match? I wonder if I can just do match because of all the derivs. I can do match. Oh, that's cool. That's interesting. And why doesn't it want? Wait. Oh wait, it's macro. Obviously, it wants format. No, I learned a shortcut to redo the indentation, so I don't have to reselect and press the key again. Okay, can I just do? Wait, no, I can't do self. Do I check for recursion? I mean, I shouldn't be able to recurse in this case. I mean, it should be checked beforehand, right? I mean, it should be symbol. Try read unwrap. Now I need a lot of testers to test the compilator because there might be a lot of errors. In case like you do a recursive evaluation, and in some places it might error out. In some places it might just crash and say unwrapped somewhere. That's a kind of a problem. Let's symbol equals symbol match symbol type. I mean, I need to do r hash, right? Fill match r. Ooh, fill match arms. Why did I fill match arms? I don't know. I should have just left one of them because I don't need the others. Okay, so the symbol any other will return none, and here same thing. What's wrong? Expected span type, font type. Oh, so I can't. Okay, I do need inner here. Inner. Okay, now here module. I can have a symbol value. Wait, evaluated. So let some value equals symbol evaluated. Else I return none. What's the quick way to return none? This. And I think I can even do this. Ooh, that's fancy. I can actually do this. But I think I'm still gonna do this. Now why did this indent? So module should return an optional. I mean, I should see. Technically, I should get all those those traits out because it's impossible to develop inside. I probably should do this. We go to README roadmap. Oops. Get metadata traits out of macros. Because I mean those traits can be huge, as shown here. This is like the biggest metadata trait in the whole project. And it would be nice to get them out of macros, especially now I can actually do this easily, relatively easily. Except like the whole macro is basically recreating a trait, except adding those contracts and then adding those impulse. And I mean, can I actually wrap this into a trait? Oh, wait, not the trait, a macro. I don't know. We'll see. Anyway, so module value. I wonder how the type inference works here. I mean, not type inference, the IntelliSense and stuff. As ref, it kind of works here, which is surprising. Okay, so let module equals this module. So we have symbols. I mean, I can just do get name, and that's like all. That's like pretty much it. Because this is a symbol reference, right? Stores a symbol. Oh wait, no, it stores a symbol. I mean, I can just do symbol reference, symbol. Which I can actually. Can I take a look? Yeah, I do. I do wrap it in. Oh, I do a lot of wrapping. Can I do them all with maps like that? Probably no. Okay, I can do symbol of symbol as ref internal pointer new. Okay, now symbol evaluated out. Cannot move out of the reference of this thing. Oh, then borrow, I guess. No. Yeah. Type inference. What I'm gonna do here is not prefix with an underscore, but instead do this. So that then IntelliSense actually names this argument correctly and not the underscore. That's something I learned from Zig. Okay, now this thing should work theoretically. Oh, we need to fix the parser, obviously. And the parser also needs to do the thing. Parser needs to parse the colons. Okay, so first of all, in this unit expression thingy, we check if there is. Oh, wait, actually, we do it here. Sim reference. So we do let. Oops. We do let reference equals this. And then we do if, or actually while parser. See, look, recursive descent for the win. Match operator. Operator colon. While it matches, we just do reference, which we should make mutable, by the way. Equals symbol reference. No, it doesn't. Recursive descent for the win. Box of spend. Sure, up spend. Reference. Let's move this thing here. Like how easy it is to parse binary expressions without parser combinators. With recursive descent for the win. Reference. Then we have a name. Parser expect ident. Symbol. I guess. And then we wrap this in spend. Parser wrap spend from the start. You want to play another basketball game? Score 1, that's because I scored 1 plushie at some point, resetting the score to 1. Let's see. Expected struct, box of spent, font spent. Yeah, I need to wrap this in a box. Easy. And this expected orcus span font option of span. Wait, what? Oh, expected end. What's the first type of expression that you try to parse? What do you mean? What do you mean by that? Like, you want me to explain how parsing works here in the Orco parser? What is this? This is a name. Let's let some name equals this, else break. Well, I like if let. Just let else. Like the first type of expression, I mean, additive, I guess. So we have this function that actually we have this function that parses an expression. What it does is it checks for a return keyword, then it returns a return. No, recursive parser combinators first try to parse expression in one way. If it fails, it goes to another way, etc., etc. But recursive descent, here how it works. For like my parser, and I mean recursive descent is only the part where you do. Well, I think at least I think that recursive descent is only the part where you do. Well, actually no, the whole this thing is recursive descent. So we start with if there is a return keyword, then it's a return expression. Then we expect another expression after the return keyword and return this thing. Then if there's let, we can just gloss over this. I mean, we can just skip it. Too much stuff to explain. Else, we expect this to be a binary operator. A binary, I mean, just as I explained, recursive descent parsers to work. It don't even know what it does. Oh, it goes on. Does this function also parse? Oh, blocks? No. So if we look at binary goes to another binary which is one level of precedence deeper, because this is just a compressed. Here it contains 4 levels of precedence. Anyway, this function, when it goes to some point, it calls unary, which is just as I explained recursive descent parsers, calls unit at some point. And then the unit expression actually parses parentheses and braces. So unit expression, if there is parenthesis, we just parse an expression. So this is for the case, for this case, for example. Then we have an error, extern keyword, fn keyword, module keyword, if keyword. Here block. Here is a block. So if we match a left brace, then we parse a block. That's basically it. Okay, so where was the colons? I guess I've done it, right? I think it's done. Error function put s is not defined. What? Still too complex for you. Oh, I think I know what this is. PC arrows. What does this mean? Oh wait, parser combinators shift right 3 times. I mean, it's too complex for you because my parser is complex. And I didn't bother making it simple. Anyway, why are you panicking? Function put s not defined. I think what happened is names. think what happened to the names. Oh, you want to study my parser a little more? I mean, you can go to GitHub and look at it. Um, Parser combinators. I mean, parser combinators are slower. Well, actually, for JSON, they're gonna be about the same speed. Well, actually, no. When there is an error, when there is invalid JSON, they're gonna be slower. Well, actually, I mean, you should think about the target, the end users. If you're writing a library or a compiler, or any application that anybody else except you is gonna use, you should think about end users. Think about people with Asus Triple EPC, which has 1 GB of RAM, and Intel Atom as a CPU. Think of those people who are sitting days and nights at their computer and waiting for the Rust toolchain to compile, which they can't compile it because it's 32-bit. This CPU is 32-bit. This was me uh, um, 3 or 4 years ago. Yeah, 3 or 4 years ago I had Asus Triple EPC. Uh, Come on. This was me 3 years ago. Those don't deserve your language. Can I focus? I wonder if it worked. I mean, theoretically it shouldn't. We didn't. Okay, nice. What? Um. Okay, I'm glad it didn't. But I should probably actually enable commands for this chat. Okay. Anyway, we get an error probably because we declare functions. Okay, so at least this thing should work, right? Put s. Why it just says put s? What? What? Oh, I know why. Because symbol reference to a function. Yeah, so this is inferred already. And since this is inferred, it's just a function put s. We don't know what put s it is. It's gonna work. It's not gonna work for 16-bit computers. You understand this, right? It's only not gonna work for 16-bit and 8-bit and architectures. Because you're literally passing user2 into it. That's the point. The point is this. The point is it's gonna work on a 32-bit machine. This is the point. Don't know what's the point of code actually, so I'm probably not gonna use it. Okay, so we should probably fix the display of those symbol references. So this is still okay. You literally said those people don't deserve your language. Uh, Okay, so I can't find display. Oh, it displays at the top above metadata here. So in the symbol, I mean name. The name. I need the past, not the name. So I wish I could actually put the path in here. I mean, we have a name, which doesn't really matter. I mean, do we make it a path? We can make it a path, or we can just make a path. Symbol path gets completed at type inference stage. Path. Oh wait, path. Path empty or what? Path new. Okay, ensure evaluated. I mean, this is redundant. This is redundant, so but still, it is so useful. Mod RS. Talk to someone who knows both Rust and Haskell. Talk to QHuman. That's the only person I know. Oh wait, no. Tom Marks Talks Code also knows Rust and Haskell, I think. And he streamed today. Wait, I don't know Haskell, but I want to learn it, honestly. IR.
Иди к папе. Не пойдешь? Не пойдешь?
Okay, so where's the type inference? Here it is. I'm just blind. Infer type inference. Oh wait, this type inference has a current module. Yeah, I need a current module, a root module, and current module path is also here. Ooh, yeah, I should probably populate those things. Symbol path course type inference current module path extend not a q extend symbol name. Okay, hold on. Okay, that's a mess. Anyway, path. Wait, we need to lock it. Can I provide a path? Wait, I don't need to. There's type inference here. Symbol locked. I mean, do I really need the path? I don't want to add redundant path. Operator expression, symbol reference. I mean, you can store it in symbol. Instead of always making mapper in Rust for option result iterator. Instead of always making map for Rust in Rust for result option iterator and impl method, could have made it an impl trait method for implementing a functor trait. This is in Haskell. Doesn't map actually come from an iterator trait? I think map actually comes from an iterator trait. If we go to docs.rs, I don't know where. Either std Rust. What? Rust std docs. So if we go into option, it is sum, as ref, as mute, as slice, as whatever, expect, unwrap or else, unwrap. Okay, it is map actually. Where's an iterator then? Where are iterator methods? Wait, did I just see unzip? Hold on. Okay, so those are iterator methods. I don't know where iterator methods start. Is it actually... There is an iterator, no. Or is it not an iterator? It is into iterator, it's not an iterator. Oh. Yeah, I mean, they could have implemented an iterator for an option. Theoretically. Or something like that. Options. Because you can loop through them, you can do for. That's because they implement into iterator. And same thing for results. Okay, so let's actually go in and fix this error. So I guess what happens is if we go into wait, where is it? Impl iterator, or you mean into iterator? Okay, so oops, actually function as into iterator, yeah. I mean, it's not. Those are all just functions. Just iterator is Rust function functor trait, but it's not used, which is why. I don't know. I mean, to be honest, if they are concerned options to be just iterators, and this is not something they want, then I'd say they could just extract it into a functor trait and add it as a trait bound. But then Rust becomes a functional language. Okay, where is this parser? What am I doing in parser? Function. I want to go into backend. Here, backend. Convert function signature, build function. Define function. Okay, where's declare? Here, declare function. Declaring function a name. No, it's not difficult. Closures in Rust are just the closures are just how they should be for a compiled language. Even better than how they can be. This should be path. So we have declaring function. Declaring compiling. What? Wait. What? Okay. Be right back. Okay, we're back. And I want to try to add a window capture to the be right back and starting soon screens, so overlay is visible. What is this? Oh wait, it's a microphone. It's a bad microphone. You can probably hear everything. Okay, now this thing should be right. Overlay. Goodbye. Audio. Yes, sure. And it should probably go webcam, video, audio. Here. Now the overlay should be displayed in all the screens, and I should be back live. I mean, I am back at Breaks in Progress. Sure. Okay, so it's kind of sad that I came back during the ad. Well, not really. Not really that I came back during the ad. Did actually anything happen? Yeah, I know, kind of true. Rust is kind of too low level to be a functional language. I kind of agree with it. But at the same time, Zig is, I mean, functional first class are different things, but Zig is more first class. So maybe we can say it's more functional than Rust, and at the same time, it is much more lower level. So yeah, Rust isn't just isn't designed for this. Okay, so function put s. What's wrong? So we have pass to string, declare function, name. Huh, interesting. And here's an ID, and I insert as a path into it And then when I reference it, where's the symbol reference for the backend? When I reference it, a symbol a variable build constant value. What? Oh wait, a function call. A call. Where's a call? Call here. I ran out of my water.
Okay, let's go.
It's like the cup is empty now. Okay, I guess I'm refilling. I mean, is it worth it? Okay, if there will be no hydrates left to the end of the stream, I'm not gonna refill it. Because I did get a little bit. But the cup is now actually empty. And I'm clicking on the wrong. Wait, what? Numlock? You at least can see it. Okay. What is that? Oh, it's a webcam, which you'll never see, hopefully. Or actually, which you hopefully will see soon. When I get a webcam. Well, soon. When I get a webcam, then you'll see it, I guess. Okay, here. Get past single symbol name clone. No, that's not it. Okay, so I do need a path. So I do need a path, and then I go to symbol. Oh wait, I mean symbol already. Symbol locked dot path equals type inference path current module path extend symbol locked name clone. Okay, so now I fill the path. Now here I actually use symbol path instead of symbol name. It's so weird to use symbol name here actually. At least we caught it, which is great. Okay, now if we go to symref, oops, symref, not here, symref, come on, this one. Okay, here in the display I should also then use path. And now this should compile and work and be nice. No, it doesn't. Oh, missing path. Oops. Path equals self path clone. I mean, not equals, just is. Okay, now it should work theoretically. Unused import super. What do you mean? An expression with an s, I guess, sure. Okay, so function put s is not defined still. Huh. Symbol path. Okay, now if we look closely here. Oh, we don't update this thing. Yeah, obviously. I forgot that we don't update it. We need to update it. If we go into mod rs, ir mode, here. It's evaluated. So when we infer and check types for the module, I need to do type inference current module equals module. That current module equals type inference module equals module symbol locked does not live long enough. What? Oh no, I hate this. But I guess we should do an internal pointer here. Oops. Oh wait, internal pointer requires it to be pinned. Don't know what to do then. Now I'm fighting the borrow checker again. I mean, I can just do some unsafe manipulations here, but yeah. What do you mean current module? Oh, wait, 1 R versus 2 Rs. Symbol lock does not live long enough. Yes, I understand this. Type inference current path module path push module name, or what it is, symbol locked name. Pop. So what did we do with the return type? With the return, I think we just cloned it. Or did we do an internal pointer? No, we just cloned it. But I mean, we can't clone a module here. It's even just a reference. Name EE. Please never be in the same city as you. Will not be able to compete for Rust jobs. There are not much Rust jobs. But I mean, should I say that please don't be in the same country as me then? Because here you, I mean, can't say that my country is like that bad, but we don't talk about politics on stream. Well, not really. Oh, it path doesn't have pop. 0 pop. Here. Now, a lot of errors. Cannot move out. Yeah, sure. Here I can clone. I mean, I should clone. Clone. Lifetime may not live long enough. Yes, this is the problem. See? I mean, can I mean, how do I, like, replace? I mean, can I pin it? I mean, I can probably pin it. Pin. How do I pin this thing? Pin new, I guess. Let module equals. I mean, it's gonna be dropped at some point. And here I'm gonna do internal pointer new out of a module, which is gonna just be qualified as an internal pointer. Okay, so this is gonna be an internal pointer then. Internal pointer. Oops, can qualify that. Then this. Ooh. I mean, can I do P? Can I wrap this in pin? I'm pretty sure I can, but this is kind of weird. Let root module equals pin new root module. Pin doesn't do anything. Wait, no, I can't just do this. Oh wait, it's pin qualify. Okay, now I can do internal pointer new. Qualify. Now here can just do a mutable reference, and then I substitute it back. Okay, so here I have a module, then I substitute some stuff, then I inference check types and bring stuff back. What? Qualify a pin? You want me to qualify a pin? Now you're qualified. Qualified to do Rust. Okay. Now this thing should work. LD. Undefined reference to libcput. Why does it use libcput? Like when I do... Oh wait, I think I know why. In librs, or no, in module rs here, I in the external function here I use function pass extend function name. Instead, here I do function what, I don't even know, name, I guess, external function name. So this is not a symbol name, it's a function name, and in this case I do symbol name. Pass a single expected pass phone span. What? Wait, what? Come on. Cannot move out. Sure, clone. I have to clone here actually because of maps and inserts. Or I should replace those by references, which we'll experiment with. Now it's still libc put s for some reason. At least this is a libc put s. But here I declare function as import with name put s, just put s, because function dot name dot clone. Declaring function put s. Yeah, we've declared put s. Why is it libc put s? Oh wait, function libc put s is not defined here. Huh. Oh, I see. I see. So pass s path option import s path. I'm gonna say import, but this is also gonna apply to export. So this is gonna be option of path import as name actually. Let me do option of a name here. Or actually just a borrowed string then. Import as name unwrap or this. So we can trick Crane Lift into thinking that this is a different thing. And here I do none, and here I do let me undo this to the point where this was this. So here I do none, and here I do this. Okay, now it should work. And it doesn't have to be path. It can just be this as a string. Let's see, as ref, like that. Oh wait, this has to be sum. Okay, now still function libc put s is not defined. Huh, that's weird. Path is okay, so we're declaring function. Oh wait, we're not even declaring it. What? Huh, what? Wait, did we just hit a bug? Wait, no, it can't be true. Why are we not declaring it? Why are we not declaring anything in the module? It was working. What? Did we accidentally cut out something here? Build module. I mean, I am building the module. What? libc, which is a module, equals module function test, put s, which is external function. I don't understand. What's wrong with it? Don't understand. Okay, I guess we're taking a break. 15 minutes. Wait, 15 push-ups. Why minutes? No, not 15 minutes of push-ups. Ah, okay. Now we are refreshed. Nigel, did you do push-ups also? If you redeem push-ups, you have to do them as well. Freedom decided to do so. So I guess you should also comply. I should also ask my viewers to do push-ups with me. Oh, oh, that's hard. No, how do I actually fix it? Oh, I guess get the workout. I'm pretty sure you're gonna get better than just 15 push-ups. Okay, so no. My Now how do we fix this thing? Imported name. We have imported name. Huh. Function name. But wait, symbol name. But I mean, it doesn't really matter here. So this is just a path of a function. Wait, no. Well, I can now actually do. Yeah, actually, I can do function pass and symbol pass, but it doesn't really matter which one. I can do symbol pass, but I leave this. I feel like this is better. Cloning is same anyway. Name clone. Huh. Don't understand. Why are we not declaring it? We are not declaring anything in the module for some reason. Wait, I know why. Oh no. This is random. Look. If I run it enough times, it's gonna work, see? Okay. Thanks God it started with not working. Okay, so I guess we'll do declare module declare all symbols in a module. I'm just gonna cut this out. Cut out. Now here I need to move the module. I mean, not move. Here I leave the build, and here I put declare module. Okay, now this thing should work reliably every time. No, it doesn't. Function wasn't declared. What? What? Now that's interesting. Compiling module, compiling function. Wait, oh, That's simple. I haven't declared anything. Wait, how is the function not declared? Wasn't declared then? Oh, because it's yeah, compiling functions. I should make this more make sense. Compiling function that wasn't declared. I thought it was like searching for a function that was not declared. Okay, so where's the librs in the backend? Okay, so here we do declare module and then build module. Okay, now this works 100% of the time. Look at how fast the compiler is. And it's compiling the whole libc. If I'm gonna cut out the libc, it's gonna be even faster. I mean, compiling, it's linking with the whole libc. Well, actually, it's kinda slow. Because the linking part is like instant. But we don't have incremental compilation yet, and we don't have any caching, and we don't have multi-threading yet, so I'm gonna say it's good enough. And readme, we can actually cross those off. Pass an operator cancelled, or passes borrowing name. Oh wait, no. Let's git add this. Git commit -m pass git push not push now. Orcopath is borrowing names without is. Let's rephrase it a little bit like that. Now, pass pass were here, but they are not. They are not. Okay. So now we can go to librs of the Orco itself and make pass borrow names. Vec of borrowed name. It's gonna make that's gonna be much different from other stuff. Lifetime. Oh yeah, lifetimes. I just wanna try this. Yeah, right. I'm just doing those changes. I wanna try doing this if it's possible. Lifetime A. Oops. Root. Borrow of lifetime A of the name. Link. Paste. Okay, now display for path with. It doesn't really matter. Okay, now this thing won't compile and will give a lot of problems. Well, actually, not much errors. Because we haven't got to the backend yet. Okay, hold on. Symbol now has a path. Oh, that's gonna be a problem. That's like our first problem. Because this thing borrows all the names. And it can't read it. So, okay, scrap this idea. No. This is not possible. I mean, maybe it is, but it's not worth it. Because pens are still pretty simple. Cancelled. Next we have get a metadata out of macros. Okay, some simple entries, and comp times in blocks. Maybe I'm gonna cancel this one as well, because I'm not sure. I'm not really sure about it. Because I need to export the functions, or like not export, but at least build them in order to use them. Okay, so get metadata traits out of macros. If I go to librs, I think. Wait, it's ir modrs actually. So here we have a huge macro, which instead should probably just implement stuff. Okay, so let's do. So first of all, let's rename the macro to metadata. Just metadata. Should still work, right? Works just fine. Okay, now we can do nothing which yields all of those traits. So this is contracts. Contracts yields just this. I mean, I'm not sure if it's allowed, but should be theoretically. What? Expected semicolon phone count. Okay, sure. And then we have a trait which is ident. I'm gonna do impl for trait trait. Okay, now branching. If I go here, metadata contracts, is it gonna work? That's the question. Probably no. But worth trying, I think. And it's not testable properly. I should have made it testable first. Okay, let me just yank this macro. Then let me reset all of that. Let me put this here and go to expression mode res. Function has metadata. Okay, if I do this, metadata contracts, it's gonna work. Expected bang, what? Expected an item. What, you don't want to work with macros? Doesn't work with macros, sad. Okay, I guess contracts I have to write them myself. That's kind of sad. That's where I prefer C++ preprocessor. I can't say this. So I just need contracts. Well, actually, I can do a trait metadata, which implements all those contracts, and then I can put this single trait as a contract to this one. Metadata. And then I do impl metadata. Impl metadata. For a trait, well, actually I can do multiple traits here then. Like that. But no, I'm gonna do it for one trait. Oops. Okay, so here, no, here. Actually, scroll this up. So here, where here, impl metadata. Wait, no, here. Okay, fine. Impl metadata for trait function metadata. Not like quite as compact, but I mean, this is like 2 more characters, one more line, and much better experience. Here, this is my this one is even more compact. Conflict implementation of clone for type box of function metadata. What? What? Excuse me? Pull metadata. Oh, what? Oh, wait. That's because I'm dumb. This should be external function metadata. Now, what's wrong? Oh, let's read this one. I mean, I can import metadata for this. Okay, and now, oh, this should be public. Implement this trait. Then I'll have implement metadata. Okay, and now this thing should work, right? Wait, this should be public. I forgot to make traits public. Public. Okay, now this should even compile and work, right? Yay, it works. Okay, now we're cooking. Now I can. Oh, this is already implemented for a module. Does a module have does a module need metadata? I would say it does. Metadata. Module. Wait, where? Function rs. I can go. No, function mod rs. Function mod rs. Here, I can copy how I do metadata. Okay, derivative debug. Derivative debug. Default block actually like that. Module should probably have a metadata. Module metadata. Okay, clone. I don't know why, but sure. Let it be. And the module metadata. I copy it from a function, like a comments for a module. Front end metadata for a module. Okay. Now a module should have a metadata. New metadata. Okay, what's wrong? Oh, docs. Create a new module. Okay. Missing docs. Docs are here. Okay, should work. Yep. Now constant public trade metadata so we implement them. All right. What string? Okay, now now spend symbol reference. Okay, the thing also has a metadata somewhere here. Make this public. Metadata. Okay. Impl metadata, symbol metadata. Okay, next we have binary expressions, same thing, and unary, and all this stuff. Public train binary metadata, impl metadata, binary metadata. Okay, easy enough. This will probably all go away when traits are implemented. Okay, operator done. Unary block. Same thing. Okay, if expression. Now what's here? If meta, obviously. Same thing. Okay, three things left. Oh wait, actually one thing left. This is the last one. Or should be at least. Should still compile. Okay. Okay. And okay, librs. Wait, actually no, irmodrs. Here. I should be able to remove should be able to I should be able to remove this macro. And it should still compile just fine. Okay, it does. Oh wait, hold on, committing. Readme. I should tick this off. Parent modules. Get metadata traits out of macro. Okay, let's also compile the calculator. Calc, I said. 2 plus 3. 3 to the power 4. Classical tests. Maybe I should wrap them in tests, actual tests, like. So you can cargo test. Actually, cargo next test run. Is this gonna work? Should work. I think it should work. Now, can we do a full libc bindings? I mean, what is to bind there, actually? Like, until we get imports. Failed to resolve, could not find me yet in Orcom. Okay. Ooh, yeah. Unit tests, or I mean, just tests. Oh, just tests are haven't been updated in a bit. Source. Okay, this is not how you make source, I guess. Or it's just not imported. Oracle. Why is it not imported? Good question. So, which contains private fields. Oh, new. Wait, what? Source. Oh wait, I don't need this thing anymore. That's the same. Okay, now. Type alias report as excuse me? Call librs. Public use diagnostics asterisk. Okay, get me to the tests. The tests haven't been updated in a while. Oh wait, what? Oh, that's because diagnostics are re-importing it. Okay, parser ident. Let me rub those percentage. Oh wait, oops, undo. Rub those in. Oh wait, I can't. That's not new. I have to do parser ident new of this link. Paste. Yep. And this is what number? Oh, those are numbers. Okay, so here we do this and we do false. Okay, right. Oh, wait, this goes, oh no. Hold on. This should be, this should actually go here. And here I can do ink after the text. And this one is actually gonna be true. Okay, tests, please. Use parser span. Wait. Wait, parser, not parser ident, parser ident. Parser ident. What's the shortcut for replacement? No shortcut? Okay, now it should work. Now it should test all the stuff. Whoa, all tests pass. Didn't expect to fix it that quick, to be honest. Okay, Cargo Clippy says a lot. Oh, maybe. Maybe that's true. Wait, what? How is that? Equate only cares about this for some reason. Oh, that's, yeah, that's fine. This if else if can be collapsed. Okay, sure, collapse it. I mean, I don't really like it collapsed, but fine. Okay, 2 plus 3. Me to the power 4. And fix tests and Clippy warnings. Tests are at least working. They are not testing much, and I should write more tests, but they're at least working. Okay, what do we have here? Parent modules should be relatively easy. And I'll move traits here, and I'll leave them for tomorrow. I'll do parent modules, which should be easy, like this easy. Simple Orcom. Okay, so this test function is gonna call. First of all, let's actually test the thing. I really need a test. I really need to set up like black box tests and stuff like that. I need to find the tests for a compilator. Yeah, I really need some tests. Okay, we can spend tomorrow writing tests actually. Writing tests. Write more tests. Oh, I'm pressing A when I was meant to press S. Okay. So this is the same module. Oh, it's simple. And I should call the libc test. Test. Okay, this works. Now, what we want to do is to create a comp time test here. Close function should not be confused, which is gonna run the test. In create test. In libc test super test. hello world, and then I just call libc test. So this is not gonna work. At least this thing is not gonna work. Because there is no super test. Wait, libc put this, obviously. Okay, now let's make supers, which should be easy. Relatively easy, at least. Module. Wait, no, not this module. IR mod rs. Okay, so here's the module. And now the module will have super, or parent actually. Parent, which will be like internal pointer. Parent of this module, public parent, which is an option of an internal pointer to a module, I think. Well, can I just do a module here? I'm not sure, but at least any default implementations will leave the parent as none. Just clone, I mean, I'm also gonna reset parent here. Okay, so parent. Well, actually, okay, so it's not that easy. No, come on. Why is it so hard? Those back references, they are bad. They are so bad. I mean, I can try simplifying, not simplifying, but doing path. Path. Okay, so I mean, I know what I can try. We go to a symbol reference. Here at the bottom we have a default implementation of resolving. Global symbol, so resolve scoped symbol. Here if we do, I mean, it's so hard. So if self is, if this is like super, then I need to get a scopes parent, which means I need to resolve the whole path again. Well, if it starts with super, ooh, I don't know. It might not be possible. I'm not sure how to do it. Seems so easy, but it's not. Actually, I think I know what I can do. Okay, if we go to back to module, should work. So if I redo the parent of this module, which will still be an option of an internal pointer. So, to module. Okay, so here I set parent to none. Field at type inference stage. Well, type inference stage is more like everything stage, everything resolution stage, and then there is type checking and type finishing and checking stage, which is everything checking stage. Even warnings are generated at this stage. Well, not lints though. Parent. Okay, here I can do parent none. Do I panic if the parent is not none? I can if self parent is some. Modules with parent cloning modules with parents. Basically, this is unimplemented. Okay, now. 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 We actually need to fill this parent in ensure evaluated and symbol probably is the best place. Type module, same thing basically for the function. Okay, so I set the symbol path here. Like in the module, so if function, for example, checks here, module runs checks. Before it runs in front check, module parent, but after it's evaluated, equals self-type inference. It's actually parent module, which is an internal pointer to a module. How convenient. But I mean, it's not really possible to make it an internal pointer. I can make it an internal pointer to a symbol. Huh. Okay, so this is unsafe, first of all. My unsafes are really breaking Rust. Using internal pointers too much, yeah. So this is not pinned. So it's not gonna be pinned. Oh, by the end of the scope. How do I... Can I actually reset it? I mean, do I have to use the symbol? Can't I just use a symbol reference instead of module here? Option off. Symbol reference, literally. Wait, it's resolved. What? No. Wait, symbol reference. So I need to get a current module, which is now the parent module. I need to get its a reference to it. Module parent module symbol reference. Qualify this. Now the thing. This thing requires an option of symbol reference, so I can just clone it. I do sum of parent module clone. I mean, do I really do symbol reference, or do I do something like an internal pointer to an RWLoc of a symbol? I mean, I need to represent root as well then, somehow. Okay, this is actually much harder than I expected. Um, 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 huh. So do we need self as a symbol reference? Somehow. Which and it is borrowed at the same time. Nice. I guess we do symbol reference. I don't know what I'm doing. It's to self clone. Okay, we're cloning for now, temporarily. And here I can actually provide reference to self. Wait, no, I don't mean here, I mean here. Probably. Symbol, it's just a symbol, RWLoc symbol, it's too high. Let's borrow for WLoc symbol. Oh wait, no. Can I really? Okay, so this is a reference to an RWLoc of a symbol. Okay, this is complex. Where am I calling this function? Ensure evaluated. Here. Symbol is a pin box actually. I mean, I can make symbol a pin box, a reference to a pin of a box of this, and it should be just fine with it. Then I'll have to provide reference to self, which is a symbol, which I'll need to wrap in an internal pointer. Well, actually, this should be not a pin box probably, but a pin ref. Now, and then I do symbol reference symbol. This is a mess. Expected pin of reference, found borrowed pin of reference. Oh wait, I don't need to borrow pin of reference. You're right. Okay, so this is a reference to self, which is a bad idea. Yes, ref. Can just do this. Oh no. Here, ensure evaluated. I need to provide. What do we need to provide here? The reference to a parent module. Oh, I can't. That's a problem. That's the problem. I can't provide it. Okay, discarding. Let's discard all of this again. Reading simple.org. Discard. Okay, so what do we do then? Symbol reference. I mean, what do you mean? P-mutable reference. We've removed all of this, come on. Restart language server. I mean, we've changed the files and it doesn't know about it, so makes sense why it didn't restart it by itself. Anyway, why? What's wrong? I mean, what's wrong? How do you implement it properly? What would be the better way to implement it? Because I can't really have a module's parent. I mean, I can theoretically combine them to a global path, but that's annoying. If I just do supers, I mean, I can do like parent path, scope access, can do like parent access, but I don't know. I mean, I can try this parent access and root access or something like that. I mean, I can add roots. Freedom Slave. I can add roots pretty easily. This time actually easily, and I have everything for this ready. Or is it? Or is it? Okay, actually no, it's not. Come on. Come on! It's not easy. The crates one. But I mean, I can actually do like parent access and crate access. Is parent access easy though? Is parent access easy though? Yeah, I can do crate access like that, but let's do parent access. Unresolved symbol from a parent scope. Okay, now from parents scope, I guess like that. Even like that, I guess. Okay, so do we need to make it like number of times U32? This is absurd. Again, bizarre. So thing is here, parent access, okay. I need to do this in where? Where do I have a clue? In expression mode RS. Here in clone. Where's the clone? Here. Where's simref parent access, whatever. Hmm. Okay, so parent is basically the same thing as this, but type inference gets symbol. Search settings. Oh wait, search settings scopes. So it's instead of current module, I'm gonna have like parent module, which is hard. Oh, I didn't know it was gonna be that hard. Okay, let me reset all of this. We can do um, um, module root access. Basically the same as unresolved now. Okay, this one I can do for sure. Okay, so there's like nothing to resolve really. So I can just do type inference root module get, wait, not get ref, read, try read. What is this? A pin of reference to a module. So oh, symbols, get name. Well, that's basically it. I mean, should I extract this to resolve root symbol? Should probably name this to resolve symbol. Metadata resolve root. Why is it so hard, by the way? Why is it so hard to just get the module? We have resolve symbol. Because I can't get a reference. Makes sense, well, makes sense. Because a module should not be a reference on by itself. Well, I mean it should, but okay, then root tax doesn't really make sense. Okay, I'm not gonna do this. I'm just gonna end the stream. Yeah. I'll think how to do modules, and then we might do crates tomorrow. Wait, traits, I mean. But yeah, we did some work today, and I started streaming kind of late. Okay, well, I lost a follower. That's kind of sad. Anyway, anyone I'm following his life. I mean, everyone I'm following his life. But first of all, we need to check if there is a compiler dev streamer. Compiler. I always hate this Twitch browser. Let me just search on Twitch. It searches even in the title. I mean, obviously there's no one. 2 days ago. Writing a compiler for the Rimbird. I would trade them if if they were streaming today, right now, but they are not. So I guess Freedom. I haven't traded him in quite a bit. What's Soul doing? Also some Rust. 8 times in the last 30 days. We haven't traded them recently. Bonus.
Be straightforward, I hope.
Ooh, 8 minus.
And yeah, when we finish that, maybe we'll get to a little bit more of manipulating the companion and working on the stun,
At least my rates
stuff like
are
that.
getting more
How do you
interesting.
do, Infinite Coder? How do you do? You're just in time for the anti-pre-roll ads. Yippee!
Okay. Goodbye, YouTube.